There you go. So yes, we did this a lot last year. We're going to add something to it. Instead of having just an equal sign there, there's going to be an inequality in there. So let me get rid of that equal sign. And if you look at down here, your inequalities, there are four options. Less than or equal to, greater than, no, sorry, less than, greater than. Then there's less than or equal to, greater than or equal to, right? Remember those? You've used them at some point, I know that. So if you, what happens when you insert that? What happened to the graph? It's no longer just a line, is it? There's a bunch of points shaded above the line here. So it's saying it's not just interested in the points that are right on the line, it's also interested in all the points that are above the line in this case. So we can zoom out indefinitely, and the whole pane above it is shaded. What if I were to flip this sign the other way? What if I go, instead of greater than, you always read it from left to right. Greater than, I get rid of that, and I insert less than. What happened now? You see that? Everything below that line got shaded. And I will teach you how to do that. We will focus a lot of time at first not dealing with word problems, and then towards the end we're going to focus a bit more on word problems. So that's basically the main difference here between linear equations and inequalities, right? So I'm going to review a little bit. I'm going to assume you forgot a lot as to what happened in Intro to Applied and Pre-Cal. We call it IAPR. So go to page 3 with me. And okay. So first, slope. It's a numerical value that indicates the steepness and direction of a line, right? So it will tell you two things: how steep it is, and the direction of the line, whether it goes up or down. Okay. And here are slope. We used M for slope. And remember rise and run. I think you remember that. Rise over run, that's what it is. You can also think of it as the vertical change, right? The vertical change over the change in horizontal displacement. Too many fancy words, right? Calculate it. You can calculate it like this: y2 minus y1, which gives you the vertical change, x2 minus x1, which gives you the horizontal change. So these are all connected. You probably were given these in 3 separate formats, but really they're all the same. They're all saying the same thing. Okay. And so it turns out that we have 4 types of slopes. That's how I narrow it down to. And I'm going to use a red pen. I don't know what you have, but you can have a positive slope, right? And so from left to right, we're going to be going up. It doesn't matter how you want to read your slope. What matters is that from left to right, it's going up. Okay, so you're the first one with this new booklet, guys. So from time to time, I'm gonna kind of wonder what I did, right? So diagonal. First of all, if it's going to be a diagonal line, and rises from, I'm just going to go left to right. And I'll say this: diagonal line, x and y are present. Very important to remember. When you have both x and y in your equation, it's going to be a diagonal line. Negative slope. Obviously your line drops. It's still a diagonal line. And how do we know that? X and Y are present. And I'll tell you something already. I'll give you a warning. Sometimes you can have X and Y present at first, but when you combine like terms, the Y's or the X's might cancel out. And that's when you're truly going to know whether or not this is a vertical or like, you know, if it's a diagonal or not. And this one drops from left to right. So I'll tell you also, if I rush a little bit through this, and you're like, whoa, 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 I need you to slow down because I remember doing this, but I don't quite fully remember. That's okay. Later when I go into actual inequalities, I'm going to repeat some of these things quite often. Okay, so don't despair just yet. The third type of slope is called undefined, and this is a vertical line. I'm going to scroll up here already, like that. So your vertical line, you should know, goes up and down. So it doesn't matter where on here you want to do it, right? Goes like that. Slope is undefined, not zero. Sometimes students mix up undefined with zero. It's very different. Why is the slope undefined? This is why. If you were to calculate the slope, right, you would get a rise. There would be a number there. But is there any horizontal change from one point to the other? Nope, there's no horizontal. So this turns out to be zero. And that's why it's undefined. If you grab your calculator, mine is charging, I think. I listened to the teacher and I left mine here overnight. And 5 divided by 0, let's say, it'll say error, cannot do it, divide by 0, cannot do it, right? So if you press 2, go to, it will say there's something wrong with this expression, cannot do it, right? So that's why it's undefined. And so you need to be able to say that. And so the equation would be x is equal a number. Does that ring a bell? Axis of symmetry. Remember, is x equals a number? And I'll say no y variable present. That's how you know it's a vertical line. There's no y variable. So it's not a diagonal, it's a vertical line. Then you have the zero slope. It's a horizontal line. This would be like the equation of the min or max. Remember that one? So if you were to calculate your slope here, let's first draw our line. I'm just going to grab a random place and draw that red line. There you go. And in this case, your vertical change, like if you grab any 2 points on this line and try to find a vertical change, it'll be 0, right? You don't rise at all. Where were we? There's no vertical change, but there is, you would find some sort of number for horizontal change. That doesn't matter. The focus is on where is the 0, right? And 0 divided by anything is always 0. That you can say for sure. Should I say up here, this is undefined? Yeah, so you're not thinking, oh, there's a 0 there. I wonder if it's 0, right? I hope you would know by now that it's not, right? Equation would be y is equal to a number. There's no x variable present. So if there's x and y present, you know it's going to be a diagonal line, right? For sure. If there's no y variable, it's a vertical line. If there's no x variable, it's a horizontal line. Okay? That's what it is. So these are the 4 slopes. I hope you remember vaguely what's happening. These you should have covered last year, right? We're not going to deal with parallel lines or perpendicular lines. We don't worry about that in this course, even though you might see it. Right. Let's keep going here. Lots of stuff to review. Graphing linear equations by hand. You need to be able to do that. Another graphing checklist, right? X and Y axis labeled, appropriate and consistent scale. You have arrowheads, label line with equation, right? So there's nothing really new here. What I want you to do is, I made a note for myself here. I'm helping you out. I know what's coming down the pipe, right? So I will say this. Combine like terms. I will always ask you to do that. Okay, combine like terms when you see them. Okay? I don't know about you, but I see 5x and 2x. You see that? There's a 5x there. There's a 2x there. No y's. It could be y on both sides, but that's besides the point. So I'm going to keep this 5x there. And the 2x comes over. I know some of you didn't learn it that way, but it's another way of thinking, right? When it comes over the equal sign, it comes over subtracting. And now in retrospect, I should have done more of different colors when I showed you how to use the quadratic formula. Sometimes I assume that everybody just knows how to do it. So the 2x comes over, and I put it right next to the 5x so you can see it. I tend to leave the constant. I tend to leave it on its own on the other side, and you'll see why in a bit. So 5x minus 3x is, 5x minus 2x is 3x plus 2y is equal to 6. That's what I would suggest you do. That's the format that I would suggest you put them in to make it easier to work with. Now you know for sure this is that diagonal line. Diagonal line, because you know that could have been that the x or the y canceled out, but in this case both variables are there, so it's a diagonal line for sure. 2 methods of graphing. I'm gonna prefer this one, but either one is fine. Okay. Method 1 is find the x and the y intercepts, calculate the intercepts, and then connect those. So this is how I do it. And I teach it the exact same way in IAPR if you were with me. I don't think anybody in here was, but you dodged a bullet. Right? X-intercept, y is equal to 0. Y-intercept, x is equal to 0. Just for now, I'm going to make that note there. I'm doing them right side by side, and I'm using this one here. You see it? This one right here. I'm going to say 3x plus 2, 0. I don't do this down the road, but I'm just going to show you that one example. So you let y equal to 0. You want me to make an arrow? I'm going to make an arrow from here. Connect. So just saying, hey, I'm using that one to come up with this. So 2 times 0 is just 0. So you end up with 3x is equal to 6. You divide both sides by 3. If you can do anything for yourself, especially after today, is be good at doing this, right? Finding the intercepts. So we know that when y is equal to 0, x is equal to 2. So I state it like this to make sure I know this is an x-intercept. Then I do the same thing with the other side. I'm going to go 3 times 0 plus 2y is equal to 6. 3 times 0 is just 0, so you end up with 2y is equal to 6. Watch for negatives. You could have a negative 2y, right? In this case, it's not, so we just divide both sides by 2, and you end up with y is equal to 3. So now you know when x is equal to 0, y is equal to 3. There you have your x and y intercept all in one place, right? Neatly displayed, easy for you to find. And now we graph this thing. So, and the intercepts help me to come up with a scale. I know this is small enough. I'm just going to go 1, 2, 3, 4, 5 to the right. And I'm going to go 5 in every direction. Later on, it's going to get a bit more complicated. But for now, we're just going to go with 1 at a time, right? So 1, 2, 3, 4, 5. So I have a scale of 1, and I'm just going 5 in each direction, okay? So now, I don't know, some teachers might have told you need 3 points to graph. I don't know if you remember that. Did some teachers tell you need 3? You actually only need 2 for linear. And these are the ones. So 2, 0 goes right there. 0, 3 goes right here. And you're done. So grab your ruler. I picked a nice and easy example, by the way. It won't always be that nice. The numbers may be decimals. That's okay. You put it kind of ballpark where it's supposed to be. Okay. I'm going to put my equation on here. 3x plus 2y is equal to 6. And that's it. You're done. X and y is already labeled. Right? I already did that for you. That's it. You're graphed as a straight line. What's the second method? Very similar, but different approach. I take the one from the equation I rewrote, this one, and I'm gonna go up and bring an arrow down just so you can see where I got that from. Okay, 3x plus 2y. That's standard form. Do you remember? There was general and then there was standard form. You don't need to remember that. I'm just trying for you to see the connections. So what I'm doing here, watch the steps. Rewrite into this form, right? This is the slope-intercept form, right? Where y is isolated, and then start with the y-intercept and find another point using the slope. So we're going to rewrite this. So 2y is equal to this negative, this is going to come over subtracting, right? 3x is positive. When it comes over, it's negative 3x plus 6. And what happens now? Anybody remember? You get rid of the 2y. This could have been negative 2y, 500y, it doesn't matter. Whatever is in front of the y, you divide both sides by it. Whatever you do to one side, you got to do to the other. And then you go negative 3 divided by 2. You can't really get that, so I'm just going to leave it. And you do not need to simplify this one. I know that in IPR they told you to do that. No need. You leave it as is, okay? Plus 6 divided by positive 2 is 3. So that's the rewritten form, okay? I know that my y-intercept, just by looking at it, is 0, 3. That's coming straight from, there are no brackets, right? So you can just take it. I'm giving you a foreshadow, like next year, that's what you're going to remember, that constant at the end is your y-intercept. And my slope is negative 3 over 2, which is down, right? Points down. points down. How do I know that? Because my slope is negative. Okay. So now I'm going to do the same grid. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 each way. Later on, I'll show you some tricks how to come up with better scales, because you're going to have tens or hundreds. Could even be, thousands. It doesn't matter. So going back to this, the only point you know for sure is 0, 3. You plot that 0, 3. And here I'm going to use maybe 2 different highlighters. I'm just going to show you that the negative 3 tells you you're dropping 3. So 1, 2, 3. So I'm going to highlight that like this. And you're running 2. So it's going to be 1, 2. Right? So that's your next point. And you're actually done there. You can keep going. You can go 3, 2, 3, 2, right? As many times as you want to, but this is it. Okay. So this is start here. Start with y-intercept, right? And then I'll say, oh, this is going to be in the way, so I'm going to have to redo this one. Find second point using slope. Okay. And I'll clarify something because I feel like this might cause a problem later. So you extend that line way past those 2 points. Those 2 points are just to give you a reference, but you make sure you extend it across the whole graph. And let's not forget about our equation. Okay. And I think I'll just make a side note right here. If you ever, when you do your calculation, it may be that you get this, right? You have the negative in the denominator for whatever reason, because you divided both sides by -2. I always tell my students the negative always floats up. So just rewrite it like this. That way you only have to worry about is the 3 going up or down, but you're always running to the right when it comes to your horizontal displacement. So I would say stick with this one. Okay, negative floats up. Okay, so you're always running to the right. It's just a matter am I dropping or am I going up as I'm moving to the right? So that way you're not having to worry about that. Okay. We are going to use our calculators shortly. So let's keep going here. I think I'm going to ask you to practice go to page 6 for now. Page 6. And the I got punched out. Anyways, I want you to determine the intercepts here. Then I want you to rewrite it into y equals mx plus b. And then I want you to use to graph it using a method of your choice. Either the intercepts or starting with a y-intercept and then finding the second point. Okay, so this one is already the way I would suggest you have it. This one down here is not quite. I would suggest you bring this 25 the negative 25 over to the other side, and then start working with it. So always try to make it look like this, the x, the y, and a number. Okay? So how about we just try A and B? That's all I'm going to ask you to do before I move on. Okay, so A and B for now, and then we'll go over it. So I'm just briefly going to go over these so you have them right, and then I will tell you to do the rest on your own. So here we go. X-intercept, y-intercept. This is how I do it. So this is basically 4x is equal to 18. Right? You divide both sides by 4. And that's 4.5, right? And is this the right question? Yeah. 4.5, so 4.50. And then for the y-intercept, you let x equal to 0, so it's negative 2y is equal to 18. And so you divide both sides by negative 2. Watch out for that, right? 18 divided by negative 2 is negative 9. So 0, negative 9 is your intercept there. Nice packet, right? Rewrite, sure, no problem. So it'll be negative 2y is equal to negative 4x plus 18. Right, the 4x comes over to subtracting, divide everything by negative 2. So this is positive y. Negative divided by negative is just 2x. 18 divided by negative is negative 9. This should jive, right? These should be the same, or else you made a mistake. So that's what I'm after there. And now let's graph, and we need to make sure we account for the negative 9. So I'm going to go 2, 4, 6, 8, 10. Right? 2, 4, 6, 8, 10. You can go different here if you want. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. X and Y is labeled. 4.5 goes right about there. And negative 9 goes here, right? Because this is 8, 10, so negative. And we know that 2 is positive, so we did expect it to go up, right? So here we go. Draw your line. There we go. Arrowheads. And it's y is equal to 2x minus 9 if you want. You can grab that one if you want, no problem. Okay? We're good? No complaints? No comments? Okay. This one, I'm just briefly going to do this. Bring 25 over like that. X-intercept, y-intercept. X-intercept, that would be 6x is equal to 25. Divide both sides by 6. X is equal to 4 point something. 16, 166 keeps going, so it's 417. 417, 0. Y-intercept is negative 5y is equal to 5. Right? Divide both sides by negative 5. Y is equal to negative 1, so that's 0, negative 1. Okay. Oh, no, I made a mistake, right? You're calling me on it. I could hear something in the air. Yeah. 25. This is negative 5. Negative 5. You know where I would have caught it? Probably when I rewrite. I would have caught it there, most likely, right? But you were first to the game there. So I'm using this one. Negative 5y is equal to negative 6x plus 25. Divide both sides by negative 5. Y is equal to 6 over 5 positive, right? X minus 5 right there. I'm using this as my method, so 5 everywhere seems pretty good. Spread that out a bit more. There we go. 417 is right about there. 0, negative 5 is there. also pointing up, and I did expect that, right? Did anybody use the, in this case, using the slope would have been difficult because you're starting, no, actually it would have been fine. Starting with that, so you would have gone up 6, so 1, 2, 3, 4, 5, 6, and over 5, right? So you would have been 1, right, like over here somewhere, 5, 5, 1 right here, right? So that's fine. You would have had the same line. You're talking about the same line. So this is 6x minus 5y is equal to 25, and that's it for now. I'll tell you, I'll give you a heads up. If you go back to page 5, these ones cancel out, like either the x or the y variable cancels out. So I'm going to ask you to try that at home. Basically anything 5 to 7. How about we write it down here at the bottom of this homework, pages 5 to 7. But I'm not quite done yet. This is believe it or not, this is still review from last year. And if you can try even like 2 or 3 questions, because I do throw some curveballs in there, you can do it. And remember, you can multiply both sides by something. If you see fractions, I would get rid of fractions ASAP. So if you see half on this side, it's like I'm going to multiply the whole thing by 2 across the board, get rid of fractions, right? And then move stuff around. So 8, what's up with 8? That's just in case I assign some homework questions from the textbook, which I don't think really happens. You can use these grids to graph if you want. So let's go to page 9. This is where we start talking grade 11 applied. Okay, this is where we ideally you would have just done linear equations with in grade 10 and then joined me here with this unit right after. It gets more fun, I would say, with this one. In this course, we will be using graphing calculator, right? A graphing calculator to determine the characteristics from a line or lines. So this is the key here. Rewrite all equations. You have to rewrite them like this. This is just in case I teach this before quadratics, right? So we know how to enter it into our calculator. We know how to enter them into y1 or y2 or however many we're graphing. But look at all these stars here. Look at that. That's crazy, right? It's almost like one of those forms you say I agree to, right, on the internet, and you have no idea what's underneath there. But anyways, always clear all old equations. Plot 1 needs to be turned off. You would know why at this point because you're entering an equation manually. You only have the option of using x as a variable. If the first value is negative, we use negative, not minus. And then press graph, okay? So I won't explain the window either because you know how it works by now, right? How to change your window parameters. But look at this. If your window parameters are not set to where the line is visible, you will completely miss it, right? So you have to change your window so that you start seeing the intercepts, right? X and Y intercept for sure, and then move on. We don't have a vertex, right? So we don't have to worry about that with linear equations. So come with me to page 10. I don't think I need to talk about zoom either because we've done a lot, but here it is. Zoom standard gets you to a standard window. It resets it. Zoom fit, we've tried that sometimes. Some of you have tried it. No, it does not change the X-min or X-max. It will only change the Y-min or Y-max, right? The zoom fit, most likely. So it will make it show up, but you might have to change your X values. Zoom 9 is zoom stat, only be used if you perform a regression. I think you all know that already. Keep going. Graphing using technology. When we prepare booklets as teachers, and I think everybody's guilty of this, we have these amazing ideas, and then we realize we only have this much time to cover everything. So that's why sometimes I just skip over things, but you already know that anyways, right? The zoom functions. Graphing using technology. For each one of them, rewrite graph on calculator, find the intercepts using technology. Watch this. Determine the y value when x is 7. Determine the x value when y is 15. It's like, what? There's too much going on. Just follow me, okay? You'll be fine. So let's do this. Let's rewrite first and foremost. This one would be 2y is equal to the 6x comes over positive, and the 30 is already there. Okay, the 6x came over. It's not positive. We divide everything by 2. I picked nice and easy numbers here, by the way. You're welcome. 3x plus 15 is what you get there. This is basically I, right? So we're done. We have it written the way we want it. Y is isolated. Graph on calculator. Let's do that. Which way is this line pointing? First of all, it's diagonal because I've got both variables. Okay, check. Slope is positive, so it's going up from left to right. My y-intercept is 15, right? So all these things come into play. I'm going to clear everything that is on y, so press y equals, right? And then you go 3x plus 15. And let's go graph and see what happens. Hey, I actually see it. But it's more than likely that you use it for quadratics, right? So let's go zoom 6. Let's all look at the same screen. So zoom 6 is zoom standard. There's my x-intercept, but you can tell that the y-intercept is outside the window. So we go window, y max. I'm going to go what? 20 for y max, 20. Boom. There it is. That's all I need to see. Intercepts. We're good to go. So let's graph that. Sorry. What is it asking? Graph it. We did it. Right? We did this. Check. Using the calculator. Find the intercepts. To find the x-intercept, what are we going to do? We're going to let y2 equal to 0. And then we're going to go second, trace 5 for intersect. Let's find it. I'm going a little fast, right? I know. Y2 is equal to 0. And then hit graph again. So we're going to find that intersection between those two lines, which will effectively give us, you just hit enter, 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 because it's a linear. You don't even have to go close to it, right? That's the only x-intercept that exists. So that's, look, -5, 0 exactly. Perfect. The y-intercept, do I need the calculator for the y-intercept? It's 15, right? We're going to go through the motions anyways. Second, trace 1, and then we're going to let x equal to 0. So second, trace, value, x is equal to 0. It'll find that one up there, which is 0, 15. I already knew that. We knew that. But hey, it doesn't hurt to refresh that. 4. Determine the y value when x is equal to 7. You're given the x value, right? So we're going to go second, trace, value, x is equal to 7. Warning, I will give you these values that are way outside your window. I will give you values here that are like -500 or something. And you're going to have to make sure your window changes to find that point. Okay, so right now we're taking it easy. Second, trace 1, x is equal to 7, and we get 36. We're lucky. So 736 is way up here somewhere. In this case, the calculator was still able to give us the answer. But once you get too far out, it's not going to find the answer. So we're just going to trust it and go 736, right? Y is equal to 36. Let's change, should we change our window? No, we'll leave it. We'll leave it. 5. Determine the x value when y is equal to 15. We let y2 equal to 15. And then second, trace, intersect. Okay, so let's go to y equals. We'll let y, oh, we know that it's 0. Why did I do that? Anyways, let's just go with it. The other one is not going to be like that, right? Second trace 5. It is 0, 15, right? X is equal to 0. There we go. So we kind of went through the motions there. I want to do the other one at the same time, okay? So let's do the same thing for the other one before we go. And after this, I'm going to be done. Watch this. It looks kind of messy, doesn't it? You should recognize right away, hey, I've got like terms, right? I have this there, and I have the negative 4x there. Like terms. Combine them, okay? Combine. And I'm gonna kind of massage this so that I have it the way I want it. So I'm gonna go negative 4x, and the x that's over here comes over, subtracting, right? This x comes over subtracting. I have the negative 5y on this side of the equation, but I'm just bringing that term behind it. What should I do with 100? I will bring the negative 100 over to this side. Why don't we use a red pen as well for that one? And just say, hey, that one came over. So I will make an arrow here, and I will make an arrow here. Negative 4x and negative x is negative 5x minus 5y is equal 100. And I can see that last year your teacher said, hey, do you see that they all have a common factor of 5? Let's divide the whole thing by 5. You can do that if you want. I'm just going to leave it. But I asks us to rewrite this, right? So we go, no, yeah, I'm asking you to do that. So negative 5y is equal to 5x positive. So the 5x comes over plus 100. Then I divide everything by negative 5. Very careful with the signs, right? Y is equal to 5 divided by negative 5 is negative 1 x. And then 100 divided by negative 5 is negative 20. And there you have it. Slope tells me that this is dropping. It's a diagonal line. It's dropping, right, from left to right. My y-intercept is at negative 20. Watch out for this. I actually want you to figure out how to graph this on your calculator. Take a minute. Type that in. I will type it in already, but I will not show you how to make it appear on my calculator, on my screen. Take a moment.